Hi, welcome to this On Maths prediction for the Edexcel GCSE Maths Foundation Paper 2. Enjoy! Hi, I'm Chris Gilpin and I hope that Paper 1 went well. From what people are messaging me, it seems that it went okay. But a lot of you are looking to revise for Paper 2 and 3. Now remember, Paper 2 and 3 are not really that different to each other. It's basically a 3-hour paper split into two. So when you revise for Paper 2 and 3, as long as you've got a calculator in your hand, you're good to go. Don't forget that all of the stuff that we're going to see in this video you can do on the site, completely free. If you go to onmaths.com, I'm sure there's a link coming up there now. And on the site also there's topic busters. In fact, we're finding that on the site many people are now going to the topic areas and revising specific topics, which is fantastic. Like I always say, don't rely on this prediction as an absolute this is what will come up. It never works that way. What this prediction does is it first of all gives you some practice of GCSE style questions. It also, I've removed all the stuff that's come up in Paper 1 so that you can practice the topics that are more likely to come up. Especially ratio and proportion. Don't think because ratios or proportion questions come up that it can't come up again. All the exam boards have shown that they have repeated some topics. Probability is a good example as well, because probability has loads and loads of different types of question, and although probability may have come up in Paper 1, it doesn't mean it can't come up in Paper 2 and 3. So the safest bet is first of all focus on the calculator questions, because it's unlikely there's going to be ones that require not a calculator but you've got a calculator in your hand. They're not going to come around and take the calculator off you. These are now both calculator questions. So during this half term and during up until the exams, have your calculator in your hand. That's your best friend now. You don't need to worry about the non-calculator questions. Other than that, revise everything. If you go to our site, there's loads and loads more stuff. We're adding more stuff all the time. Such as Demon Questions, the Revisionator, etc, etc. We're making a few changes to the site, so please just have a look on the front page and just see what's going on. And I hope you enjoy this video. Thank you very much. So in this question we're asked what name this polygon has. Now polygon is just a shape that has an amount of sides, poly meaning many. So we've got to count the sides first. So we've got 1, 2, 3, 4, 5, 6, 7, and a 7-sided shape is called a heptagon. Now many students know that it's a septagon. Heptagon is a better answer, don't ask me why. Next it says how many sides does a hexagon have. Now I always got pentagon and hexagon mixed up until someone told me that the x in hexagon is the x in 6. So from then on I know that a pentagon has 5 sides and a hexagon has 6. So a hexagon has 6 sides. It's really important that you know all the names of the shapes up until a 10-sided shape. So this question is asking us to convert worded numbers into just numbers. So it says 2,605. So when we're thinking about numbers, we think about what column each of the digits are in. So we have our units column here, we have our tens column here, we have our hundreds here, and we have our thousands here. So we have 2,000, so I can put a 2 in here, 600. Now it doesn't say any tens. If it said 35, I could put a 3 in the tens column, but there's no tens in that number. So I'm just going to put a 0 and 5. Now when you look at that number, you think, oh, that's 2,605, and that's what it says in the question. So that's our answer. Okay, for this question, we've got a ruler next to a line, and all we need to do is read off how long the line is, and it says the ruler is showing centimetres. Now a really common mistake with this is to write down 4.1. If I zoom in on that little bit there at the end of the line, you can see that there are 4 little notches there. Now, the most important thing we work out with this question is what are each of those notches worth? So it's going to be 4.0 here and 5.0 here. Well, it's going to be, if we try 0.1, so we can try 4.1, 4.2, 4.3, 4.4, 4.5, so it's not going to work. So it's going to be 4.2, 4.4, 4.6, 4.8 and 5. So therefore they're going up in 0.2s, not 0.1s. So the answer is going to be 4.2, not 4.1. So in this question we're given a train timetable, and we've got 4 towns. We've got Ashcook, Flute, Risetown and Coalip. And the bus is obviously starting at Ashcook and then finishing at Coalip, passing through these towns as it goes. So it says that we arrive at 2017 at Ashcook. Now we will have missed this train and we'll have missed this train, but we'll be in time for this train, so we'll take the 2032 train. Now that will stop at Flute at 2052, but we're looking to see how quick we can get to Risetown, which is the next stop there. We'll get to Risetown 21:24. So this question asks us to write the smallest odd number. Now there's 2 instructions there. We need to make the smallest number from the digits, and it needs to be odd. So to make the smallest number, we want to use the smallest digits on the left hand side of the number and the largest digits on the right hand side of the number. Okay. We also need the last number to be odd. Now to make a number odd, the last number needs to be 1, 3, 5, 7 or 9. Okay, so looking at the largest numbers, the largest number is 6, so we want to end on a 6. However, 6 is an even number, therefore if we end on a 6, it will be an even number. So we've got to look at the largest odd number, which is the 5. So the 5 is going to go here to make the number odd. Then we need to use up that 6 next. And then the next largest number is the 4, and then 3. So my answer is 3,465. Now always just check to see whether we've answered the question. It says it wants the smallest odd number. Well, that's an odd number, and I can't think of a way of swapping those digits to make it any smaller, because we've used the smallest numbers we can on the left hand side and the biggest on the right hand side. You will need to be familiar with the names of 3-dimensional shapes. So the one we have here is a triangular based prism. So a prism is a shape that you can cut anywhere along one of the axes, so anywhere along here, and it would look exactly the same. It would look like a triangle. The first bit of this, triangular based, is just the name of the shape at the end, the name of the shape at the end of the prism. So you can have a hexagonal based prism or anything like that. It says write down the number of faces. So the faces we can see, well, the face we can see here is a triangle, so that's 1. Then we've got 1 along here, which is a rectangle. So we've got 2 that we can see, but there is also going to be a third one round here, which is also going to be a rectangle, a 4th one at the bottom, which is going to be a rectangle, and then a 5th one round the back, which is going to be a triangle, just like number 1. So in total there are 5 faces. Try and remember what a face is. A face is something you can lay your hand down flat on. An edge is something that you can run your finger along, so that's an edge there. And vertices, or vertex, is something that if you put your finger on, it would be pointy. So there are going to be 6 vertices. For this question we need to understand the difference between multiples and factors. multiples are just a numbers times table. So the multiples of 5 will be 5, 10, 15, 20, etc, etc. Now every number in the 5 times table ends in 0 or 5. So looking at the list of numbers we've got here, there's only one that ends in a 5 or a 0, which is 10. So 10 is a multiple of 5. Now factors go the other way. A factor of a number means that the number, so 24, is in another numbers times table. So 24, and the easiest way to find the factors of 24 is you start off with 1 and 24, because 1 times 24 is 24. Then you go 2 times, 12, 3 times 8, 4 times, and you think how many 4s? 6. 5 times, well that doesn't work. 6 times we've already got. So those 8 numbers are the factors of 24. Then I look at the list, well, already there's a 24 there. Is there any other ones I could have written? I don't see any other ones, so 24 is my answer there. 2 prime numbers. Now prime numbers mean they only have 2 factors, 1 and themselves. Okay, that's a prime number. If there's any more factors, it's not a prime number. So let's go through the list. 10 is in the 5 times table, which we identified in question A, so that's not a prime number. 24, well, we've listed out 6 other factors of 24, so that's not in it. 18 is 3 times 6, so that's not going to be it. 17, I don't think of any times tables that 17 is in, so I'm going to say 17 is a prime number, which it is. And 19, well, I can't think of any times tables 19 is in, so I think that's a prime number. Let's go through the rest to make sure. So 16 is 2 and 8, so that's not a prime number. And any even number apart from 2 is not going to be a prime number. 2 is the only even prime number. 27 looks like it might be, but actually 3 times 9 is 27, so it's definitely not. And 28 is another even number. So it looks like we found the 2 prime numbers. Okay, so we're given a number machine. The number machine has an input, then we times it by 4, then we add 9, and then it has an output. Okay, this time this is different to normal, this question, because it gives us the output. So we have 53 here as an output. So when you're going the wrong way through a number machine, you inverse the operation. So instead of a +9, we do the opposite of that, which is -9. And instead of times by 4, we divide by 4. Okay, so we're going to have our 53, and we're going to take away 9. So 53 take away 9 is going to be 44. Then we're going to divide it by 4, which will be 11. And we can check that by putting it back through the number machine, and we should get 53 out. So 11 times 4 is 44. 44 plus 9 is 53. So our input is 11. Okay, so for this question we're asked to construct a pie chart from the table. We've got a number of frequencies. Now the first thing to do is work out how many frequencies we've got in total. So first calculation I'll make is adding up all the frequencies, and that calculator tells me is 24. Okay, now the problem we have is a circle has to add up to 360, and at the moment all of our frequencies add up to 24, so we've got to find out what we're going to multiply all these frequencies by to get them to add up to 360. We do that really simply by doing the calculation 360 divided by whatever the total of the frequencies are. So 360 divided by 24 on the calculator equals 15. So this 15 here, if we multiply all 3 of our numbers by 15, we will get the amount of degrees we need each colour to be. So I'm going to add an extra column here and say angle, and I'm going to do 14 times 15, and it's 210 degrees. 7 times 15 so 105 degrees, and 3 times 15 is 45 degrees. And let's just check this. Let's add them up. 210 plus 105 plus 45 equals 360. And then you need to plot it onto the pie chart. Now, I don't have a protractor on this, so I can't physically do it. And to be honest, it's much more helpful to physically print this out, do it on a piece of paper, and get someone to help you use the protractor if you're not 100% sure. That 210, for instance, what I would do is probably draw a straight line down here, like a mini sort of working out line, and do 210 take away 180, which is 30, and do sort of 30 extra degrees, which is going to roughly be there. And don't forget to label them, so that would be red. 105 is just over 90, and I'm just doing this roughly. I'm not even going to use a straight line to show that it's not accurate. And then label that blue, and then check that you've got 45 left over, and hopefully you do, and then label that other. Okay, so this is quite a tricky question. So we've got a set of axes and we're given a line on it, and we're asked to find the equation of the line. So let's have a look at this line. At every point on this line, okay, even points between the lines, at every single point, x is continually changing. If we have a look at the x values, they continually change. So x is a variable, x will just keep changing. But if you have a look at the y is always 3, anywhere on that line. So the equation of the line is y equals 3, because y is always 3 anywhere on that line. So horizontal lines are always going to be y equals something, and vertical lines are always going to be x equals something. So to find a coordinate, it's really simple. There's only one mistake really that people make. The first thing to do is find out what the x coordinate is. So the x coordinate is 2. And so the first coordinate is 2. Then find out what the y coordinate is. So the y coordinate is -3. Now some people think of this as starting in the middle and going along the corridor to the 2 and then down the stairs, or up the stairs. This one it's down the stairs to -3. Now it's really common for students to get these muddled up, so just remember we always do the x, so the horizontal, we go across first and then the y, which means we go up or down. So for the first question, when you're adding letters together, the answer will be a number and then that letter. So we've got 1, 2, 3, 4, 5. So it's going to be 5b. The most common wrong answer is b to the power of 5. Now that's wrong because that only happens when you times them together, when you multiply them together. So it's going to be 5b for the first one. Next one is 10 lots of f, and we're taking away 3 lots of the f. Well, how many f have we got left over? Well, 10 lots of it and take away 3 lots of it means we've got 7 lots of it left. When you're simplifying one like this, in algebra we just don't use the times sign, so this is quite a nice easy question, 10ab. Now the last one is like terms, so we've got 5x here, and we're adding 5x. And we've got a 3y here, and we're taking away a y. So when you add the 5x to the 5x, you get 10x. And when you've got 3y and you're taking away y, which is short for 1y, so we've got 3 y's, taking away 1y, we're left with 2y. Now you can't simplify that any further because they are not like terms. You can times them, but you can't add or subtract them. Okay, so the numbers in this question seem a bit daunting, but the process is always the same with this type of question in ratios. The first thing you've got to realise is, are you given a total amount or are you given an amount of food or amount of drink? Where it says in total, they spend that amount, so it's a total amount. So step 1 is to work out how many parts you have altogether. So for food, it's 39. and for drink it's 4. And this will be a calculator question, so why not use the calculator even though we can do it in our head. 43 parts. So we've got 43 parts. The next stage of this is to work out what one part is worth. So one part is worth how much? Well, you get the amount and you divide it by the number of parts. You're splitting the amount of money between 43 parts. So 11911 divided by 43. And I get £277. So each one part is worth £277. Now let's read the question. Find how much money is spent on drink. Well, drink is this one here. And the order which they are in the question, food, drink, is the order which the ratios are. So food, then drink here. So there are 4 parts. So we're just going to write drink. So if each one part's worth 277, we're just going to do 4 lots of that. And I might as well do it in the calculator, times by 4. And that's going to be 1108, so 1108. Okay, for this question we're asked to find the cost of the toffees and the fudges. Now, if we imagine that we had 2 toffees and 3 fudges, how would you work this out? Well, the cost would be 2 times 50p, and then we would add 3 times 70p. The problem is that 2 and 3 I've just made up, so that's not going to be the answer to this question. What it says though is that it wants toffees to be called T and fudges, the amount of fudges, to be called F. So instead of 2 toffees we have T toffees, and instead of 3 fudges we have F fudges. And in algebra, we always put the number before the letter and we don't show the time sign. So it's 50t plus 70f. Now be careful, it does want the cost in pence, but sometimes it wants it in pounds. So if it wants it in pounds, it'd be 0.5t plus 0.7f. So the answer is C equals 50t plus 70f. And that can be either way around. So the first thing to do in this question is realise that we're looking for possible menu choices, and realise that actually instead of writing sushi and burger we can just write S and B, and that's normally absolutely fine unless the question asks specifically to write down the words. So the way to start this is just look at sushi first and go through the combinations with sushi. So we can have sushi and ice cream. We can have sushi and strawberries, or we can have sushi and peaches. Now that's it for sushi. So I've done sushi, and now I'm going to focus on burger. So we can have burger and ice cream, we can have burger and strawberries, and we can have burger and peaches. And if you do it systematically like that, you know you haven't missed any. Okay, so the first thing to do with this question is realise that x is sandwiched between -12 and -5. And all we need to do now is figure out what the sign's going to be. So x is going to be greater than -12, but it's also going to be equal to -12 because this dot here is filled in. X is smaller than -5, but it can't equal -5 because this dot here is hollow. Okay, so this question asks us to find all possible integer values. Now it's really important we understand that integer just means whole number, or whole numbers, I should say. Integer is just a whole number, so we're looking for all the whole numbers that are between -2 and 4, and that's all this is saying, that x is anywhere between -2 and 4, but because this doesn't have a line underneath it, it does not include that number, so it doesn't include -2. This one, however, does have a line underneath it, so it does include 4. So the first one's going to be -1, 0, 1, 2, 3, and we include the 4, but we don't include the -2. So this is our answer. Okay, so whenever we're asked to estimate with a scatter graph, we're always going to start off by drawing a line of best fit. So I'm going to draw my line of best fit, and yours might be different to mine, that's absolutely fine. Now, it's asking us to estimate the height, and it's giving us the width. And that's really important because the width is up the side. So a common mistake would be to read 17 from the bottom, but the height is at the bottom. So we've got to check the scale first, and it seems like it's going up in 2s. So let's just check that. Yep, it's going up in 2s. So what I want to do is draw a line across at the width of 17, which will be roughly here. I'm going to stop when it hits the line of best fit, and I'm going to draw a line down, and I'm going to read off what that is. Well, this scale is also going up in 2s, I think. Yep, it is. So the estimate of the height would be 4 centimeters. Okay, so to work out the area of the circle, we first of all need to remember the formula, which is area equals pi times r squared. Now, in this question, we're given the diameter, because the diameter is the full way across the circle. So to find the radius when you have the diameter, you just halve it. So we're going to do 16 divided by 2, which is 8. So to find the area, we're going to do pi times r squared. I'm going to get my calculator up. Pi times 8 squared, and it gives me the answer 201.0619 blah blah blah. And 2 decimal places, that's going to be 201.06. Now, a common mistake with this is to put in pi times 16 squared and then halve the answer. That won't give you the same answer. You need to put in the radius into pi r squared. So you always need to halve the diameter. Right, so you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19. And then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which it's going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to 2 significant figures. Now, to do 2 significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in your answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400, okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88, and then we have 2 shoots coming from it. Now I need to find out which 2 numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. Now whenever we get to a prime number, we always circle it, because that's finished. So 44, we can get another 2 out of that, we'll divide another 2 out of that, so 2 and 22. 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out because that will give you 88, so 2 cubed times 11 is 88. In this question, we're asked to draw the line y equals 2x plus 3. Now, there's no x squared or x cubed, so I know it's going to be a straight line graph. Now, there's multiple ways of doing this. I'm going to do it using a table, and then I'm going to show you a few other tricks of doing it much quicker or checking that you've got it right. The first number I'm going to start with is 0, and this, what I'm circling now, is going to be a coordinate to plot on our graph. So the top number, the 0, is the x, so this is when x equals 0. And what I'm going to do is I'm going to feed that into my equation. So when x equals 0, or y equals 2 times x, so 2 times 0 plus 3. 2 times 0 is just 0. So y equals 3. Now you don't need to do this working out for every single number, but I'm just doing it to show you how I'm getting to the y. So I'm going to try the next one without any working out. So we've got 1, and so 2 times 1 is 2, plus 3 is 5. Then the next coordinate, we've got x equals 2, so 2 times 2 is 4, plus 3 is 7. And the next one, we've got 3. So 2 times 3 is 6, plus 3 is 9. Okay, and I always go back to the negatives because I can kind of see a pattern with the positive numbers. So I can use that pattern to check that I'm doing this right. So 2 times minus 1, well, positive times a negative is a negative, so that's minus 2. And minus 2 plus 3, well, if I just use the number line, minus 2 plus 3, so 1, 2, 3 will be 1. And I can notice that they're going down in 2, so 9, 7, 5, 3, 1. So let's try the next one. 2 times negative 2 is minus 4. Minus 4 plus 3 is minus 1. Minus 3 times 2 is minus 6. Minus 6 plus 3 is minus 3. So those are my final two coordinates. The next step is to plot the coordinates on the graph. So my first coordinate is minus 3, minus 3. My next one's minus 2, minus 1. Then we've got minus 1, 1. Then we've got 0, 3. Then we've got 1, 5. 2, 7. And 3, 9. Now I want to join those up with a straight line. So let's do that now. And the last step is to label it. And sometimes you're asked to draw more than one line. So we should label it. There we go. Now, I can check that this is right because all of the numbers landed on the straight line. If I had one coordinate down here, I'd always check it. You're never going to have a straight line graph that goes up and then dips down, then goes back up again. Okay, so it's an easy way to check that you've got it right. Now, I said there was a quicker way of doing this. If you have a look at the graph, the equation, y equals 2x plus 3. This plus 3 tells us where it's going to hit the y-axis. So I can plot that one straight away. This 2 is a gradient. So if I go across 1, it tells us how far up it's going to go. And I just do that a few times to get 3 coordinates. And I can draw my straight line graph from that, and I don't need to put the table. But if the question asks you to fill out the table, obviously you need to fill out the table. Okay, so the main problem with this question is that people don't know what a frequency polygon is. If you know what a frequency polygon is, I think most people will get this right. Frequency polygon is basically a line graph, but you plot these at the midpoints. So the first one's going to be plotted at 40. The next one, so if you don't know how to find a midpoint, you just find the halfway value between 0 and 80, which is 40. To do it a different way, you could add the two values together and halve it, and that works just as well. So 80 plus 160 is 240, and then halve it would be 120. 160 plus 240 is going to be 400, halve it is 200. Okay, so we're going to plot these at 40, 120 and 200. Now a different way of doing it is just plotting them halfway between the two lines. So we've got a line here and a line here, so we're just plotting them halfway. So it says frequency is 11, so looking at the scale it looks like it's going up in 2s, so that would be 12, 14, 16, 18 and 20, so that works. So we're going to plot it halfway between the two red lines that I've just shown, and it's going to be halfway between 10 and 12, so it's going to be about here. And they're quite forgiving as long as they understand the point you're trying to do. If you're slightly off it, they are quite forgiving with that. Okay, so 120 is halfway between 80 and 160, and it's going to be 18 tall, which will be here. And 200 is going to be up to 6. So let's plot these 8, 6, 4, 2, and so 6 is going to be here. Now we haven't finished yet, we do need to join them up with straight lines. So let's just do that to finish off the question. And there we go, that is a frequency polygon. Now a lot of people look at the word estimate and think, oh, let's just take a guess at it. The reason we're estimating is because of the first step that we have to do to answer this question. It doesn't mean that just have a quick punt and guess at it. With this question you won't be able to guess it correctly, or it'd be very, very unlikely. So we approach this the same as if it wasn't a group. However, we do have a group, so we've got to do a step first. This means that we've got a value somewhere between 0 and 4, including 4 but not including 0. Now the problem is that the first step in this method is to multiply these two numbers together, but you can't times somewhere between 0 and 4 by 14. So what we need to do first is find the midpoint. The reason we pick the midpoint is it's a good number to use to represent that group. If we assumed all those numbers were 0, then it would probably be ridiculously small. If we assumed they were all 4, again it would be too high. So we assume that all those are 2 because it's right in the middle of the group, and chances are that most of them are closer to 2 than 0 or 4. So we find the midpoint of each of the groups, and a way of doing this is just adding the lowest and highest value together and dividing it by 2. Or just having a look. 4 to 8 will be 6, 8 to 12 halfway would be 10, 12 to 16 halfway would be 14, and 16 to 20 halfway would be 18. Then what we do is we get the frequencies and times them by the midpoints. So it's the same as if it wasn't a group now. So we do 14 times 2, which is 28, 6 times 6 is 36, 3 times 10 is 30, and then you can use a calculator for this, so 9 times 14, have an idea of what it's going to be. Hopefully it's 126, which it is, good, and 2 times 18, which is 36. And this is I call this the fx, although in this case we are calling the first one s, so it's the fs column. And then we need to find the sum of the fs column. So we're going to add up 28, 36, 30, 126 and 36 in the calculator, which is 256. And then we're going to sum up the frequencies, which is this column here. So 14 plus 6 plus 3 plus 9 plus 2, which is 34. And then what we're going to do is we're going to get the 256, which is all our values added together, and divide it by 34. So 256 divided by 34. And I get the answer of 7.5294 blah blah blah. And to 2 decimal places, that's going to be 7.53. Now, the reason it's an estimate, as I've said before, is that we don't know that all the values in the first group are 2. We are estimating them to all be 2, even though we know that some of them will be 1, some of them will be 3. But chances are it will balance out that it's roughly going to be about 2 in that group, and 6 in the next group, and 10 in the group after. That's where the word estimate comes. The method for doing this is how I've shown it here. I don't believe there's any other methods you can use for this. So when you have a right angled triangle and you're given 2 of the lengths, and you're asked to find a third length, which I'm going to call x, then it's going to be Pythagoras. Be careful, because if there's an angle involved, either you're asked to find an angle or you're just given an angle on the side, then you'll be using trigonometry. So when we use Pythagoras, there are 2 methods that I know of to work it out. There's the algebraic method, which is a squared plus b squared equals c squared, and that's absolutely fine to use. I'm not going to use that method, because if you're happy using that method, go on, use it, not a problem. The only thing to remember about that method is that c must be the hypotenuse. Okay, now I'm going to do a method that doesn't involve algebra at all for people who are not very happy with the a squared plus b squared equals c squared method. So my method comes with 3 steps. Step 1 is just square every number that you have and put the biggest one first. Okay, so I'm going to do 7.1 squared and I'm going to do 4.6 squared. So on my calculator, 7.1 squared, and that equals 50.41, and 4.6 squared equals 21.16. So step 1's done, I've squared them all. Step 2 is the only choice you have to make. You either have to add or subtract. Okay, now this is where we talk about the hypotenuse. The hypotenuse is the length that's opposite the right angle. So go to the right angle, go across from it, and that is the hypotenuse. So 7.1 is the hypotenuse. Now what's special about the hypotenuse and why it has a special name is it must be the longest side. So in step 2, have a think, well, if we add them, we'll get a bigger number. Well, the hypotenuse must be the biggest side. So when you're finding another side, not the hypotenuse, you will subtract. But if I was finding the hypotenuse, so I wanted a bigger number than the other two, then I would add. So I'm going to do 50.41 minus 21.16, and that's why in step 1 we did the biggest one first, because otherwise you'll get a negative number. So 50.41 take away 21.16, and that equals 29.25. Okay, and step 3 is a nice easy step. It's just root it. So with this one, I'm just going to press square root answer, and then I have, so I'm going to write that down, square root 29.25, and so that equals 5.4083, blah blah blah. It says it wants its 2 decimal places, so I'm going to write 5.41 because that 8 moves that 0 up by 1. Now, last step is just check it makes sense. Well, this being 5.41 means that the 7.1 is still the longest side, so we know we've probably got it right. Okay, to start off, when you're working out the nth term, you've got to work out what the sequence is going up in. Now this is a bit weird, this one, because it's going down, but we've still got to work out what it's going up in, so it goes up by -3 each time, and you always check that it continues, which it does. This number then goes before the letter n, so it's -3n. The next step is you go backwards 1 and find out what the 0th term is. So the 0th term here is going to be 20, because 20 take away 3 is 17. And this we add on to the end here. So it's -3n plus 20. And always check it. So for the first one, n is 1. So -3 times 1 is -3, plus 20 is 17. For the 5th term, -3 times 5 is -15. -15 plus 20 is 5, which is our 5th term. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben, and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what 1 part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. Okay, I understand the temptation in this question to say that the answer is 0. Please do not write that. Anything to the power of 0 is not 0. Anything to the power of 0 is 1. Now you can think about this. If you do x to the power of 5 divided by x to the power of 5, then the rule is that you take away the indices when you divide them, so it's x to the power of 0, and we know that any number divided by itself is always equal to 1. So the answer to this question is always going to be 1. Just try and remember that. Anything to the power of 0 is 1. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100% and they went down 12%, what we're left with? Well, we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number, 0.88, is what we times the 2014 sales to get 2015. But in this question, we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is we want to do, I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8,362.50. Okay, the next question says that the sales went up in 2016, or they want to get, they have a target to get their sales up in 2016. What's the percentage increase? Now, percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, and we need to times by 100. So I'm going to divide that by 7359, times it by 100. And that gives me 66.7617 blah blah blah. So that's to the nearest percent, so that's going to be 67%. Okay, so for this question we need to work out the length of the arc, which is around here, and then we need to work out what this and this are. So we're going to do arc first. I'm going to show the examiner that I'm doing the arc first. Now the distance of the arc is the total circumference of the circle times by the fraction of the circle we've got. So you want to work out what the fraction is of the circle and times it by the circumference of the circle. So to work out the fraction of the circle we've got, well, we've got 146 degrees and there are 360 degrees in total in a circle. The formula for the circumference of the total circle is pi d, or 2 pi r. Well, here we've got a radius because it's halfway across the circle. If you imagine the whole circle looks something like that, then the 37 is the radius. So we need to first of all double the radius to get the diameter, and so we're going to do pi times 74, which is twice 37. Okay, so we type that all into our calculator, so I press the fraction button, 146 over 360 times pi times 74. And it gives me in terms of pi. I don't need it in terms of pi, I just need it as a decimal. So 94.2826 blah blah blah. Now that's for the arc length, but we also want to know what this distance here is. Well, we've already got that one. And what this distance here is. Well, they are both radiuses, or radii we call it. So that's also going to be 37 meters. So to work out the perimeter, I'm just going to get that 94.2826 blah blah blah, and I'm going to keep it in my calculator. And I'm going to add 37 and add another lot of 37. So add 37, add 37. And that gives me 168.2826 blah blah blah. Once it's 2 decimal places, so line goes down here and we've got 168.28. Now just be careful that you add on the extra bit. When it asks you for a perimeter, just make sure you've gone the total distance around the shape. Put a dot and just draw with your finger around the shape to make sure you've got all the distances. Okay, for Venn diagrams it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18 or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's 2 numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are 2 numbers that fit that bill, so that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1/4, or a quarter. Now I'm going to be using the multiply method for this question. If you've got a different method that works really well, then stick with it. But you do need to know the multiply method for the GCSE. Now the word that probably tricks most people is this one here. Depreciates means goes down. Okay, it means it loses value. So it goes down by 1.7% each year. So to work out the multiplier, you first of all start off with 100%. Now this time you take away 1.7%, okay, because it's going down by 1.7%. You can do that on your calculator or in your head. So 100 take away 1.7 is 98.3%. Then you want to work it out as a multiplier. So you're going to do 98.3%. And you just divide it by 100. And multiply is a posh way of saying decimal. So 0.983. Now anytime I times something by 0.983, it will decrease it by 1.7%. So we've got a car we bought in 1980, and what is it worth in 1985? So that is 5 years. So it's going to depreciate by 1.7% every year. So we've got the 2,245, and if we times it by 0.983 once, that's 1 year. But we need to times it by that amount 5 times. And instead of writing that times 0.983 times 0.983 times 0.983 5 times, I can just do it to the power of 5. You get the same answer. So in the exam, you can just write times 0.983 5 times, and that's absolutely fine. You get the same answer. So 2245 on the calculator times 0.983 to the power of 5, and I get the answer of 2060.553687 blah blah blah. Okay, so because it's money, it's going to be 2 decimal places. So that's going to be 5, 5. Now last thing is just to check your answer makes sense. Well, the car was worth 2,245. It has depreciated, but not by very much. 1.7% is not very much. So it's gone down, and it's lost about, say, roughly £200. So the answer makes sense. Okay, so to do this question, I'm going to start off with a number line, and I'm going to put the number given to us in the question in the middle, so 89.6. Now it says it's the nearest tenth of a second, so what I want to do on the left hand side is put the next number down. So what could it have rounded to if it was slightly less? Well, the next one down would have been 89.5, and the next one up on the other side would have been 89.7. Now to find the bounds, we just find the halfway points, and this left hand one will be the lower bound, the right hand one will be the upper bound. So that's going to be 89.55 and 89.65. Now it says it wants it as an error interval and use t for the time. So we put t in the middle, then we put the greater than sign on the left hand side, and then just the normal inequality on the right hand side. Now these two signs here will always be the same. Okay, so when you're asked to do an error interval, it's that way around. So we're going to do our 89.55 on the left hand side and 89.65 on the right hand side. Now the reason why the inequality has an equals underneath it on the left hand side is it can be 89.55 and still round to 89.6. The reason it doesn't have one on the right hand side is 89.65 would have rounded to 89.7. So if you just remember, the things in the blue circles are always that way, and the letter it asks you for, just put in the middle. If it doesn't ask you for a letter, you can just pick any letter you want. You can call it X or something. And then the lower bound is on the left hand side, and the upper bound is on the right hand side. And the lower bound's always here, and the upper bound's always here. Okay, so this question, it looks like a standard bearings question, but something you might notice is there's no angles in it. So if there's no angles in it, we need something else, and that something else is going to involve the right angled triangle here. So we can see there's a right angled triangle here, and we know that when we've got right angled triangle, we've got two sides, we can find an angle with trigonometry. I'm going to call this angle X. Now to find X, we need trigonometry, and to do trigonometry, we need to label the sides. So we've got the opposite here, which is opposite the angle we want. We've got the adjacent here, and we've got the hypotenuse here. Well, the hypotenuse is no interest. We're not looking for it, and we're not given it. So it's O and A. So writing SOHCAHTOA, SOHCAHTOA. Well, we're not interested in the H, so it's not going to be SOH, and it's not going to be KA, so it's going to be TOA. So TOA stands for tan X equals opposite over adjacent, and the opposite is 47, and the adjacent is 72. Now we want to work out what X is, so to do that we want to inverse tan both sides. Okay, let's just scroll down. Okay, so on the calculator you want to click Shift or the equivalent on your calculator and then tan, and then you press the fraction button, 47, and go down, 72. Just don't forget to close the brackets. Every time you click tan or inverse tan, it opens the set brackets. Just make sure you shut them. Let's press equals, and that equals 33.1356, blah blah blah. Okay, let's have a look. So X is 33, but we still haven't got a bearing. What we can do is work out what this one is, and I'm going to call that Y. So to work out what Y is, it's going to be 33.1. Well, Well, we're looking for a nearest whole number. So let's call that 33. And then we're going to add the right angle here. Now, the reason I know this is a right angle here is because it says that he heads west and then south. So I know that both the angle here and the angle here are going to be right angles, because the angle between all four, north, east, south and west, all four directions are going to be right angles. So I'm going to add 90. And you can do this in the calculator, or you can do it in your head. I'm going to do it on the calculator. 123. Okay, now bearings, something that we've got to remember, are always from north going clockwise. So it's always going to be like that. It's going to be that angle there. So to do that, we're going to do 360. We're going to take away the 123 because that's what we don't want. So on a calculator, 360, take away 123, and that's 237. So the answer is 237 degrees. I hope you enjoyed that video. If you liked this video, please click like. If you really liked it and want to support this channel, then please click the subscribe button. I can never say that properly. Thank you very much.